Was already in there. What? Why is this? Did I turn this off? I guess I did. I was wondering why this. Okay. Oh. Wait, did I just. What did I just do? Oh, I just need to type in my username and password again. Oh yeah, if anyone else has assignments to hand in, the pile is here. The other thing I discovered this morning when I got an email from my student is that I had actually forgotten to post the assignment to the course webpage. So I did post it this morning, or this afternoon. But also I think I still have copies in here. So if folks need other copies of the assignment, I mean, it's a little late, but it's still doable. 2.2, 2.3. I'm just going to do this. Does this help you see the board?
Yeah.
Okay.
That works, yeah.
Yeah, I know this is not the best
Yeah.
location, and I'm not really using this much. So. Yeah.
Give us a stapler.
Not here. It's in my office. So, yeah, I was gonna say you can just fold the corner over.
Yeah,
If you didn't know if the thing you can fold it 3 times and it'll stay. Okay. It is 4 o'clock, so it's time to start. It's a little bit of an empty classroom today. Not sure why. Maybe people getting assignments finished at the last minute. Anyways, so I am gonna get started with class today. Okay. So here's the agenda for today's class. I'm gonna start off by going over the agenda as usual. Today we're going to decide upon the date for the first test, as I mentioned. It's going to be in approximately 2 weeks. I'll talk a little bit more about that in a second. I didn't get any Muddy's point cards with anything written on them last class, so I don't have anything to go over today. I am going to do the solution to last class's group problem, when I can get to. And then I'm going to start continuing from where I left off. So we did 2.2.1, 2.2.2 last class. I'm going to finish off section 2.2, 2.2.3, 2.2.4, and then I'm going to start section 2.3 today. The way I've planned it, I don't think I'm going to quite finish section 2.3. There's going to be another 2.3.4, which I'm going to leave until tomorrow's class. And then I'll do section 2.4 as well in tomorrow's class. We'll see, I might be not quite finished 2.4 again tomorrow, so I might be like 15 minutes behind where I want to be. But that's going to be okay in the end, it'll work out. So, I'm not too worried about that. And then again, I've got some group problems for you at the end of class. Oh, a couple things to mention. Again, as I mentioned, the assignment is due today, the written assignment. If you haven't finished it yet, please take a good quality photo of it or scan it and send me an email before midnight tonight, or really just before I start marking them tomorrow morning. Another thing to mention, I haven't finished the 2.4 slides yet. Bad time management on my part today. So I will be finishing those early tomorrow morning, and they will be up on the course webpage probably by 10 a.m. tomorrow. So if you're looking for those slides to print off before class, they're not going to be up tonight, but they will be up hopefully before 10 a.m. tomorrow morning. And the other thing to remind everyone, there is a quiz next Tuesday. It's going to be basically on last week's material and this week's material. Everything from section 1.4 all the way up to section 2. All the way up to section 2.3 for sure, and there might be a question from the beginning of section 2.4, depending upon what we cover tomorrow. So again, this is the quiz on Tuesday. So again, there's a little bit more material to study for this quiz because it covers 2 weeks rather than just 1 week like the first one did. In general, the quizzes will usually cover about 2 weeks of material. So please try to make sure you go over that stuff this weekend. Again, the questions will be based on the type of questions that are in the practice problems and have been on the WebAssign assignments. Okay, so the next thing I was going to talk about were the dates for the test. So actually, let me just give you a quick schedule breakdown of what's going to happen. So Friday, January 24th, that's tomorrow, I'm going to be doing 2.3 and 2.4. Finishing section 2.3, starting 2.4. Then I've got this week, Tuesday, January 28th to Friday, January 31st. My plan is to cover sections 2.5, 2.6, and 2.7. That's the rest of chapter 2 will be next week. And then Tuesday, February 4th, I may have a bit of section 2.7 to finish. And once I finish that, the rest of that Tuesday's class is going to be review. So then, the possible dates for the test are either on Thursday, February 6th, or Friday, February 7th. And the test is basically going to be on chapters 1 and 2. So everything that we will have covered in the course so far at that point. So again, those are both, but this is exactly 2 weeks away. This is 2 weeks plus 1 day. So again, I'm pretty sure I have enough time, like tomorrow's class and the rest of next week, to finish chapter 2. Again, we definitely can't have the test on this day because I might have to finish section 2.7 then. I may not be able to finish it on Friday, January 31st. But so what I want to do is I want to check, have a vote in the class as to which of these days will work better for the test. Whether it's better to have it on a Thursday or better to have it on a Friday. The advantage of having it on a Thursday is it means if folks are traveling over the break, they can travel on the Friday. I mean, you still have to learn the material that's covered in that class at some point, but you can wait till over the break to learn it if you need to. The advantage of having it on the Friday is a little bit more time to study. Also, I know some people have less classes on Friday, and so it might actually make it easier to be more, have your brain more awake and stuff like that. But again, I'm going to do whatever's best for the majority of the class. So how many people feel like the Thursday is the better date for them? Anyone? One person. How many people feel like the Friday is the better date? 1, 2, 3, 4, 5. So one. But more people. Anyways, I'm not going to count. I've seen a lot of half hands, so I'm not sure. Now I know there was at least one person who was planning to travel the Friday afternoon and wanted to write the test Friday morning. If that is the case for other people, I'm happy that I will be in my office Friday morning. And if you want, like if you have travel plans that you want to make for Friday afternoon, you can totally write it on Friday morning and just talk to me and come by my office and do that. But it sounds like this is going to be the date. Again, as most of the class prefers, and I want to go on that. What else was I going to say about? Yeah, the test is going to be the whole class. There's not going to be anything happening before or after the test. So once you're done the test, you can go home that day. Yeah, it's basically an hour and 20-minute test. I mean, not that it should take everyone an hour and 20 minutes. I plan it so that it should take the average student about 40 minutes, and then that extra, the rest of the, or no, 45 minutes for the average student, and then the extra time is for people who are slower than average. Or if I've planned it badly, just to give a margin for error. But yeah. Okay. Any other questions before I move into the solutions to Tuesday's group problem? Okay. So, again, there were two group problems in Tuesday's class. I went over one of them, one of the solutions in class. This is the second of the two group problems. So I'm just going to talk a little bit about how this one works. I'm going to try one reason. Okay, so here we have the function y equals negative x squared plus 2. So the first thing I ask you to do is to sketch the graph. Because y is written in terms of x here, right, as y equals something, we're going to pick a bunch of values of x, plug them in, and find values for y. So again, the values I usually pick are always negative 2, negative 1, 0, 1, and 2. You can pick any values you want. I say at least 5 will be usually enough to generate a good graph. Don't use less than 5. You usually won't get a very good graph out of that. So okay, negative 2. Negative 2 squared is 4. I'm going to take the negative of that, so I'm going to get negative 4, and I'm going to add 2. That gives me negative 2 for my y. I take negative 1, plug it in. Negative 1 squared is 1. Take the negative of that, which is negative 1, add 2 is 1. 0. 0 squared is 0. 0 plus 2 is 2. I'm going to take 1. 1 squared is 1. Take the negative of that. I get negative 1. Add 2. I get 1. Take 2 and plug it in. 2 squared is 4. Take the negative of that. That gives you negative 4. Add 2. I get negative 2. So if I want to sketch these points, I've got negative 2, negative 2, negative 1, 1, 0, 2, 1, 1, and 2 and negative 2. And there we go, we can sketch a graph through those points. Okay, so sketch the graph. Now the next thing we want to do is to find the x and the y intercepts. To find the x-intercepts, we always set y to be 0. So I get 0 equals negative x squared plus 2. So x squared equals 2. When I take the square root of both sides, I'll get x is plus or minus the square root of 2. So the two x-intercepts are square root of 2 comma 0 and negative square root of 2 comma 0. On the graph, they will be here. That point will be square root of 2 comma 0. And here, that one will be negative square root of 2 comma 0. If I want to find the y-intercept, then I set x to be 0. So I get y equals negative 0 squared plus 2. 0 squared is 0. Take the negative, that's still 0. Add 2, I get 2. So the y-intercept here is a point 0, comma 2. Right, x is 0, y is 2. And that's this point here. Okay. So x-intercept, y-intercept, here's the graph. The last thing I want to do is I want to test this equation for symmetry. Now if you look at the graph, this thing does have symmetry if you look at the picture of the graph. How many people? Who can tell me what sort of symmetry it has by looking at the graph? Yes? Vertical. Well, we usually say there's three things called with respect to the x-axis, with respect to the y-axis, or with respect to the origin. So which one of those is that vertical one? Yeah, which is up and down is called the y-axis. Yeah, so again, knowing that terminology is important. The vertical line here is called the y-axis. So if it's that sort of vertical symmetry. It's symmetry with respect to the y-axis. Yeah. But that's yes. So again, that is one piece. Some piece of terminology I'm not particularly worried about. You can say it in other words if you want. If I specifically say with respect to the x-axis, the y-axis, and the origin, those are 3 pieces of terminology I want you to know. So if I want to test for symmetry, first I'm going to do it for the y-axis. Actually, well, no, usually I should do it for the x-axis first. I'm going to pretend I don't know it's symmetric with respect to the y-axis and test for the x-axis first. If I want to test for the x-axis, I've got to replace y with negative y. So I'm going to get negative y equals negative x squared plus 2. If I want to make this simpler, I can multiply both sides by negative 1. That will give me y equals x squared minus 2. But you can see this is definitely not the same as the equation we started with. So there is no x-axis symmetry. Okay, next we can check for the y-axis. If you're testing for symmetry with respect to the y-axis, we replace x with negative x. So we go to our equation here, and where that x is, we put a negative x instead. So we get negative x squared plus 2. So what is negative x squared? Well, negative x times negative x, those two negatives will cancel, and we'll just get x squared. So we get negative x squared plus 2. Now that is the same as the equation we started with. Y equals negative x squared plus 2, y equals negative x squared plus 2. So if we got the same equation we started with, this thing has y-axis symmetry. And the last type of symmetry we need to test for is symmetry with respect to the origin. And when we test for symmetry with respect to the origin, we do replace x with negative x and y with negative y. I will get negative y equals negative x squared plus 2. Because negative y equals negative x squared is just x squared. If I want to, I can multiply both sides by negative 1 to get rid of the negative sign in front of this. I would get y equals x squared minus 2. And we can see this is not the same as the one we started with. So this thing has no origin symmetry, or no symmetry with respect to the origin. Again, I'm just writing it slightly differently to save space on the board. Any questions about how I did this here, testing for symmetry algebraically? Okay. Again, by looking at the graph, you can tell this thing has y-axis symmetry but doesn't have x-axis symmetry. There are some things that are going to be more difficult to graph, and that's when this method of testing algebraic is going to be more useful. If graphing it is difficult, partly because the equation is really complicated or something, that's when this stuff is more useful. But on a test, I'm not going to give you any of the really complicated ones just because of the lack of time. So, yes?
If you had a parabola, right, so x squared plus
Yeah.
x minus 2, and you wanted to check for symmetry of the y-axis, would you set all the x's to negative?
Every single x that you see will replace with negative x. So if it was negative x squared plus 2x here, that way you'd also replace with negative x. In that case, it wouldn't have y-axis symmetry. Because this negative x would foul things up. Yes, so you would always replace, if you have more than one x, you always replace every single one. If it was x squared plus 2x, it has symmetry, but it's not y-axis symmetry. It's a vertical symmetry along a different vertical line.
Okay.
And we'll talk about that in section 2.6 when we talk about quadratic functions. So, yeah, but thank you for asking. Any other questions before we move on to the new stuff? Okay. So, I'm still continuing section 2.2. Okay. So I left off at the end of section 2.2.2, which is talking about that symmetry stuff. The next thing we're talking about in section 2.2.3 is a type of notation. It's called arrow notation. It's a way of sort of saying things in words using arrows instead. And what we're really saying when we're talking about arrow notation is we're talking about what happens to the y-coordinates of a graph when the x-coordinates get larger and larger. So we'll see things like this. How many people have seen this sort of notation before? Let's see a few people. Have you people not seen this notation before? Okay, definitely a couple with that too. This is going to come up a lot more when you get to calculus class. So if you folks are planning to take calculus class after this, as I mentioned, most people are in here. You will see a lot more of this in calculus. So the reason I'm using it now is because it is something that's used a lot in calculus. So I just want to talk a little bit about what this means before we move on. So this is notation that's used to describe the shape of the graph. What this is usually talking about is talking about what the ends of the graph do. If x is going to infinity, that means the x-coordinates are getting bigger and bigger, which means we're moving to the right along the graph. If y goes to negative infinity, it means the y-coordinates are getting more and more and more negative, which means moving down. So this statement would mean that if you go right along the graph, you go down. It means the graph would do something like that. The farther right you go, the farther down you go. The arrow usually read as approaches or goes to. So as x goes to negative infinity, y goes to infinity would be this one. Or as x approaches negative infinity, y approaches infinity. There's a couple things we use in conjunction with arrow notation. There's these little minus signs and plus signs that happen with arrow notation. If we see a minus sign, it means it's approaching that number from the left. So if I say x goes to 2 negative, that means x is approaching 2 from the left. X is a little bit smaller than 2, but it's getting closer and closer to 2. So it could be like x equals 1.9 in that situation. X equals negative 3 plus means you're approaching negative 3, but you're doing it from the right, from the positive side. If I see x goes to 6, that means it's approaching 6, the number 6 from both sides. So it could be 6.1 or it could be 5.9. If y goes to infinity, that means the y-coordinate becomes infinitely large. So it goes up and up and up and up off the top of the graph. If you see something like f of x here, f of x is another symbol for the y-coordinate. And we'll talk about this more in section 2.4, what that f of x symbol means. But if I say that f of x goes to negative infinity, it's another way of saying that y goes to negative infinity, y goes down off the bottom of the graph. Yes?
The negative and positive on top of the x arrow 2 and 3, or negative 3, are those supposed to be the,
That's from the left or from the right.
okay,
Sorry, are they supposed to be, sorry?
exponents?
No, they are not exponents.
No.
They're in the same position as exponents are, but because they're not numbers, they're not exponents. So it's called superscript. And it's written, and it just means it's just written above and to the right. And they're not the same thing as exponents. So if the negative here doesn't mean 2 to the power of negative 1.
Yeah.
Right, if that makes sense. So it's, yeah. Yeah, and you will see if you take more math courses, there are a lot of things that are written in that sort of exponent notation that's not necessarily an exponent. Yeah. Okay, so I'm going to do an example here using arrow notation. So there's a graph on page 102 of the textbook. If you have your textbook, it'd be great to open it. If not, I have a scanned version, which I'll flip to in a second. And basically, I want to complete these statements about the graph. So, I believe they're also in the actual 2.2 questions. So here's the question 24 there. This is the one I'm doing. Oh, it's not. Yeah, I was gonna say that the scanner resolution isn't as, or is the quality isn't as good as I'd like it to be. But anyways, so here's the graph. So the first question it asks, as x goes to 2 from the left, what does f of x go to? Well, x coordinate 2 is here. If I'm approaching 2 from the left, it means I'm approaching this x coordinate from this side, which means I'm traveling along the graph this way, right? I'm heading towards the right, I'm approaching this number from the left. As I approach it, my y coordinate is going lower and lower until about this point. This y coordinate is -2. So as x goes to 2 from the left, f of x here, the y coordinate, will go to about -2. So B. So here x is approaching -1. Oh, sorry, I did -2. X approaches 2 from the left. So we're approaching this point from the left-hand side, y goes to 3. Sorry, I think I saw someone put up their hand to mention that. This is the most common mistake to make with these guys, is if you see 2 from the left, to think of it as -2, and I clearly just made that mistake. It is not the same thing, 2 from the left and -2. And this goes to -1 from the right. So if we're approaching this x coordinate from the right, we're on this part of the graph. We're going towards this point, so the y coordinate is going to -3. C, as x goes to 0, what is the y coordinate approach? Well, the x coordinate 0 is here. If x is going to 0, it means we're approaching it from both sides. Again, there's no thing to say which side we're approaching it from. So we're approaching this point here from both sides, so the y coordinate is going to -1. D, x here is going to infinity, which means your x coordinate is getting more and more and more positive. You're going up to the right. As you do that, the graph goes down off the bottom. To go farther to the right, the graph goes down off the bottom, which means the y coordinate is going to -infinity. And last but not least, there is a part E, which is as x goes to -infinity. Where does f of x go? Well, x goes to -infinity means we're heading farther and farther left. If we head farther and farther left along this graph, we go up off the top. So the y coordinate goes to +infinity. Any questions about what I did there? Anyone confused how his arrow notation works? I will be using this arrow rotation in the future, and you will see it more in calculus. But, yeah, this is basically what you need to know about it for now. Okay, back to the slides. Okay, the last thing in section 2.2 talks about circles, and the graphs of circles, and the equations of circles specifically. So I could ask you something like, find the equation of a circle which has center 2, -1, and radius 3. How many people here know how to do that? Anyone know the... Yeah, exactly. I was going to say, anyone who's taken Math 096, again, that should have been covered, or Math 094 also should have covered it. If you haven't, this is okay. How many people have not seen equations of circles before? Anyone who's just not seen it? How many people are too shy to put up their hands? No one's too shy to put up their hands either. Wow, I don't even know what's going on now. Anyways, so what I'm going to be talking about basically is how to come up with equations of circles in this section. What do equations of circles look like? Well, a circle is all the points that are at the same distance from whatever the center of the circle is, right? So if you've got a center of a circle, every point which is distance 3 from that will form a circle. Like this is distance 3, this is distance 3, this is distance 3, this is distance 3. They all go together to make a circle. And that distance that every point on the outside of the circle is from the center is known as the radius of the circle. So one way of thinking about what the equation of the circle is saying the distance between a point on the circle and the center of the circle is whatever the radius is. This is the formula for the distance between a point in the circle and the center of the circle. It has to equal the radius. If we square both sides, we get that formula down there. X minus h squared plus y minus k squared equals r squared. This last equation is known as the equation of the circle. It's the equation we're always going to be using when I ask for coming up with the formula for a circle, or the equation for a circle. So example 6, I want to find the equation of a circle which has center -5, 1 and radius 3. Well, the key thing here is that we're going to use that formula there. So the center is -5, 1. The radius is 3. That means that -5 goes in for the h, the 1 goes in for the k, and I get x minus -5 squared plus y minus 1 squared equals 3 squared. And if I simplify that, x minus -5 is just x plus 5. Y minus 1 I can't simplify. And 3 squared is 9. So this equation here, x plus 5 squared plus y minus 1 squared equals 9, is the equation of a circle which has its center at the point -5, 1 and has a radius of 3. Any questions about how I came up with this? Again, at this point, you basically just have to know the equation for a circle. And if you're one of these people who doesn't like memorizing things, you can always remember that the equation for your circle comes in fact the distance between x, y, and hk is r. So it's basically the distance formula squared. Okay. Example 7, I want you to sketch the graph of a circle. So here, in example 7, I give you the equation. It's x minus 3 squared plus y plus 2 squared equals 4. So the key thing here is to figure, okay, what's the center, what's the radius? Well, x minus 3 squared, this number 3 is your h. It's the x-coordinate of the center. Y plus 2 I can think of as y minus -2. So that -2 there is the k, the y-coordinate of the center. And the 4 I can think of as 2 squared. So that number 2 there, that's my r. That's my radius. So if I want to sketch the graph of the circle, I've got to go to the point 3, -2. That's going to be the center of the circle. And I've got to go a radius 2 out from that. So if I go 2 up, I get this point here. If I go 2 units to the right, I get that point there. If I go 2 units to the left, I get that point there. If I go 2 units down, I get this point here. And I can connect all those. Oh, sorry, this shouldn't go above this. That point there should be the top of the circle. There we go. And that's what the circle is going to look like. So if you want to sketch the graph of the circle, again, you find the center, find the radius, plot the center, and go the distance of the radius out from that center. So in this case it's 2, and we go 2 up, 2 left, 2 down, 2 right, sketch the graph. Again, if I had actual graph paper, the graph would look a little bit nicer. I don't have whiteboard graph paper. Any questions about example 7 here? Okay. One thing to mention is that sometimes you have equations of circles which are not given in the nice form x minus h squared plus y minus k squared equals r squared. If we have something that's not in that form, we're going to have to do this thing that's called completing the square. Completing the square is something that I think I've seen a number of you ask me questions about, so I feel like it's something that people have done before. Completing the square is what you do. You turn something that looks like x squared plus bx into something that looks like x minus h squared. The key rule that you need for completing the square is that this h is always going to be the negative of b over 2. Whatever the number inside the bracket is always going to be half of this number divided by 2. Oh, sorry, the negative of it because of this negative sign here. And if we expand x minus h squared, we'll get x squared minus 2xh plus h squared. So we're going to have to put this extra thing onto here to make it look like this. And that extra thing is going to be a negative b over 2 squared. So the key thing is if we have something that looks like, let's say, x squared plus 4x, if I want to do this thing, it's called completing the square. Go ahead and say, okay, 4 divided by 2 is 2. 2 squared is 4, which means I have to add on an extra 4. And once I add an extra 4, this thing is going to factor as x plus 2 squared. And if we expand x plus 2 squared, we should get back this thing here. I know it's like a really quick explanation of completing the square. How many people have done completing the square before? How many people have not done completing the square before? Okay. I will definitely try to, in my example, sort of go over it in a little bit more detail as to what is going on in that example. But the key rule to remember is half whatever is in front of x squared. That's the key rule to remember. Okay. So, oh boy, okay, yeah. No, I'm going to do one more example just of completing the square before I do example 8. So if I just asked you to complete the square and the thing was like x squared minus 6x equals 10. So the key thing here is that the b here is negative 6. If I divide it by 2, I get negative 3. If I square that thing, I get 9, which means I want a 9 over here. And so I'm going to have to add a 9 to both sides. So I get x squared plus 6x plus 9 equals 10 plus 9. 10 plus 9 is just 19. Now this left-hand side, x squared minus 6x plus 9, turns out to be x minus 3 squared. The rule is if I have x plus y squared, it's always going to be x squared plus 2xy plus y squared. I mentioned this formula last week at one point. So the key thing is that the number in front of the x, the b, the number in front of the x, has always got to be 2y. For this thing to be x squared plus y squared, this thing here has got to be y squared. So this 6 is the 2y, it's 2 times negative 3. This 9 is a negative 3 squared, which is why this thing factors as x minus 3 squared. And now I have a square on the left-hand side. I could take the square root of both sides. The reason it's called completing the square is because it allows you to get something in brackets squared on one side of the equation. So yeah, the goal in completing the square is to make one side of the equation be something squared. So example 8 here, I have, sorry, any questions about completing the square, what I did here, how I turned this equation into this equation, before I go on to example 8? So you know completing the square is a somewhat difficult thing for people to do some of the time. But if so, most people had done it before, so hopefully, okay. So here we have a fairly complicated equation. 4x squared plus 4y squared plus 16x plus 24x plus 31 equals 0. The first thing I'm going to do is I'm going to move that 31 to the other side of the equation. Because completing the square works when we have something squared minus something times x. So, 4x squared plus 4y squared plus 16x plus 24y equals negative 31. The next thing I'm going to do is I'm going to divide everything by 4. And the reason is I want to get rid of these 4's in front of the x squared and in front of the y squared. Again, completing the square works when we just have an x squared on one side, rather than like a 4x squared. So I'm going to divide this guy by 4, this guy by 4, this guy by 4, this guy by 4, and this guy by 4. So it gives me x squared plus y squared plus 4x plus 6y equals negative 31 over 4. Again, annoyingly, there's not much I can do about that. Negative 31 over 4. I'm also going to rearrange this thing. There's an x squared plus 4x. There's a y squared minus 6y. And there's a negative 31 over 4. And our goal here is to complete the square on those two guys. The x squared plus 4x and the y squared minus 6y, I want to make both those things into what are called perfect squares. Yes, thank you. Thank you. No, that was a mistake on my part. Yep, nope, that was a plus before. So, this statement is true. If I take x plus 2 squared, I get x squared plus 4x plus 4. Right? Now where did I get this x plus 2 from? This 2 is half of this 4. Right? This 4 is that 2 squared. Right? So ideal thing is I want to have a plus 4 here. To put a plus 4 there, I'm also going to have to put a plus 4 on the other side. So I'm going to add 4 to both sides, and when I do that, this thing will turn into something squared. Again, where I get this 4 from is I'm taking this 4 divided by 2 and squaring it. The y squared plus 6y. It turns out y plus 3 squared is y squared plus 6y plus 9. Right? So if I can put a plus 9 on here, I can turn it into y plus 3 all squared. Again, the 9 comes from that 6 divided by 2 squared. So I'm going to add a 9 to both sides. So then, that first part, the x squared plus 4x plus 4, can become an x plus 2 squared. The y squared plus 6y plus 9 can become a y plus 3 squared. And then on the right-hand side, I've got to add together these fractions. This is the 4 we can think of as 16 over 4. The 9 we can think of as 36 over 4. So I've got negative 31 over 4 plus 16 over 4 plus 36 over 4, which turns out to give you 11 over 4? No. Negative 31 plus 36 is 5. 5 plus 16 is 21. 21 over 4. I have a funny feeling I may have made a mistake copying this one down, but I was expecting this number to be something which I could take the square root of. Now we've put this in the form that looks like the equation of a circle. It's x minus something squared plus y minus something squared equals something else squared. This is really x minus negative 2 squared. This is y minus negative 3 squared. And this 21 over 4 is the square root of 21 over 4 squared. So the center of this circle is negative 2, negative 3. And the radius is square root of 21 over 4. Again, the formula for the radius is really ugly here. You could simplify this to square root of 21 over 2 by taking the square root of the top and the square root of the bottom. But again, this is not much simpler than this is. And I am not going to redo it, but I may have copied down the question wrong from the book, and it may have actually been supposed to give me a nicer answer than that. That's right? Okay. Usually the questions in the book don't give you ugly things like that as an answer, but that is the radius of square root of 21 over 2, unless anyone can see a mistake I made. Any questions about how example 8 worked here? Yes, Kat. Oh, because the right-hand side should always be the radius squared. So what squared gives you 21 over 4 is the square root of 21 over 4. Squared. Yeah. The radius is always the square root of whatever's on the right-hand side. So if it's this whole thing equal 9, then the radius is 3. Again, this is the r squared of the formula. Okay. The last thing I'm going to mention about circles is semicircles and how we work with half circles, semicircles. So if we have an equation like that, x minus h squared plus y minus k squared equals r squared, and we rearrange it to solve for y, we get that. Y equals k plus or minus square root of r squared minus x minus h squared. I'm not going to go through the work of rearranging it. You'll sort of see that in some of the examples. But the key thing is there will be a step in the rearranging where we have to take the square root of both sides. When we do that, we have to add that plus or minus in. So circles cannot be written as y equals something without putting a plus or minus in. That plus or minus essentially divides the circle into two semicircles. The plus is going to give the top half of the circle. The minus is going to give the bottom half of the circle. So, similarly, if you want to solve the equation for x, if you rearrange this thing to solve for x, you'll get a plus or minus in there as well. And if you use the plus when you solve for x, you're going to get the right-hand half, the half where x is bigger. If you use the minus when you solve for x, you get the left-hand half, the half where x is smaller. So if I want to find the equation for the right half of this circle, I've got to basically solve it for x and then take the positive bit. So I have x minus 3 squared plus y minus 5 squared equals 4. I'm solving this thing for x, so I'm going to move the y minus 5 squared to the other side. Then I'm going to take the square root of both sides. When I do that, I've got to put a plus or minus on the side without the x. So x minus 3 is plus or minus that thing. And if I want to solve for x, I've got to add 3 to both sides. So I get x equals 3 plus or minus square root of 4 minus y minus 5 squared. Now here, because I'm taking the right half, I'm going to make this thing into a plus. It's going to be 3 plus the square root of 4 minus y minus 5 squared. Oops. Okay. So that's how you make the equation of a semicircle. You can also do the opposite. I can give you the equation of a semicircle and ask you to sketch the graph. Well, here I have x equals, and then there's a minus in front of the square root. So this means it is the left half of whatever circle it is. So if I want to sketch the graph of it, the first thing to do is to turn this back into the equation of a circle. So to do that, I'm going to square both sides. When I take square x, I just get x squared. When I take this whole thing squared, negative squared just gives me positive, and then I'll get rid of the square root. So x squared is 25 minus y squared, or x squared plus y squared is 25. Really, I can think about this as x minus 0 squared plus y minus 0 squared equals 5 squared. So the center here is 0, 0, and the radius is 5. So first thing I'm going to do if I'm sketching the graph is I'm going to draw an equation of the circle, which has this center and this radius. And then I'm going to take the left half of that circle. So here's 0, 0. If it's got radius 5, it goes 5 units out this way, 5 units up, 5 units left, 5 units down. So here's the circle. Oops. Now because here x was negative, I'm then going to just take the left half of that circle. And that red thing is going to be the graph of x equals negative square root 25 minus y squared. Any questions about what I did in example 10 here? Okay. So I'm going to move on to section 2.3. Now I'm definitely behind where I wanted to be in today's class. 2.3 I may actually speed up a little bit on because 2.3 is about lines and linear equations. And I'm pretty confident that if you graduated high school, you studied this in a fair amount of detail. Again, if you're one of these people who has totally forgotten everything you learned in high school, and you're having difficulty with this, please come by my office hours. I'd love to sort of do some more one-on-one stuff with this, but again, I think because a lot of this stuff should be fairly straightforward, I'm going to try to go through it fairly quickly. Yes?
What is the radius?
Oh, it's 5. Radius is 5. Thank you. Thank you so much. If my writing is ever my writing is always messy. If my writing is ever messy to the point that you can't read it, please let me know, because I am, anyways. One of the things about this particular course is I would love to be able to have a year to teach this course rather than a semester because there's enough material. I could go half the speed I'm going right now. But, I was going to say it is a semester-long course, so I kind of have to keep up the speed, which means my writing gets messier. Okay. So next thing, section 2. Oh, handouts. Where did I put my section 2.3 handouts I need to give out? Here we go. If you can take one, pass them back, that'll be great. Section 2.3 is about lines and what we can do with lines. So section 2.3.1 is about the slope of a line. Again, this is something that should be hopefully you've all covered in fairly good detail in high school. How do you find a slope of a line? Again, I'm going to try to go through this fairly quickly because I'm hoping that most of you have this down at this point, because you all have graduated high school. Okay, so the most important property of a line is a number which is known as the slope. The slope measures how steep the line is. The formula for slope is rise over run, or y2 minus y1 over x2 minus x1. That number n that you get is called the slope of the line. One thing to mention, it doesn't matter which 2 points you pick on the line, you should get the same slope no matter which 2 points you pick. So if I want to find the slope of a line, like in example 1 here, I am just going to apply that formula. So example 1, we have m. So the y-coordinate of the second point is -3. The y-coordinate of the first point is -1. The x-coordinate of the second is -6. The x-coordinate of the first is 4. -3 minus -1 is -2. -6 minus 4 is -10. -2 divided by -10 can simplify to 1/5. So the slope of that line that goes through the points 4, -1 and -6, 3 is 1/5. Any questions about that? How I calculated the slope for this slope formula? Again, this should be review of stuff that you learned in high school. That's why I'm going through it pretty fast. Okay. Oh. Okay. Slope affects the graph. Positive slope tells you it goes up as you go to the right along the graph. So if you go to the right along the graph, you're going to go up. Negative slope means as you go to the right along the graph, you're going to go down. Larger values of slope mean steeper lines. Like slope of +6 is like this. Slope of -6 is like this. Slope of +0.1 is like this. You know, it's slightly going up to the right, but not very much. Again, slope is rise over run. This is the amount you go up or down. This is the amount you go to the right when you're sketching the graph of a line. So if I want to sketch graphs of a line through this particular point, 2, -4 with those 3 slopes, this is what it's going to look like. So if we're going through the point, -2, 4. The first line we want to have slope 1. 1 we can think of as 1/1, which means the rise is 1 and the run is 1. So we're going to go over 1, up 1. And this is the line with slope 1. If we want to find the line with slope 2, 2 we can think of as 2/1, which means the rise is 2 and the run is 1. Which means from this point, we're going to go over 1 and up 2. Where's another color? I'll use this red. So this red line here, oh, -2, sorry. It's -2/1, which means we're going to go over 1 and down 2 rather than up 2. I'm moving too fast for my own good. And so we get that point there. We go over 1, we go down 2, and we get this red line. That one has slope -2. Part C, I want slope -1/2. So we can think of that as -1 divided by 2. That means the rise is -1, the run is 2. So we're going to go over 2, down 1. So we're going to go over 2, down 1. And the line here, the green line, that one has slope -1/2. Any questions about example 2 here? How we sketch graphs of lines if we know a point and we know its slope. Okay. Another thing to mention, horizontal lines and vertical lines. In a horizontal line, all points have the same y-coordinate. They're all at the same height, which means the whole equation of a horizontal line will always look y equals something. like y equals 2, y equals negative 3. Those are going to be horizontal lines. Any horizontal line has slope 0. It doesn't go up or down. Vertical line, all points are the same x-coordinate. All points are on the same place on the x-axis. That means vertical lines look like x equals something. X equals 3. X equals negative 6. Those are all vertical lines. Vertical lines have undefined slope because the x2 minus x1 is going to be 0. The bottom of the slope equation is going to be 0. You cannot divide by 0. So therefore, vertical lines have what's called undefined slope. They do not have a slope. They're too steep to have a slope. Some people also say they have slope infinity. You can think about it that way if you want, but yeah. So, okay. So if I give you something like example 3 here, we want to find an equation of a line which goes to the point negative 4, 2, one that's parallel to the x-axis. Well, if it's parallel to the x-axis, that means it's going to be horizontal. So it's going to look like y equals something. Well, the y coordinate of this point is 2, so it's going to have to look like y equals 2. If it's perpendicular to the x-axis, that means it meets the x-axis at a right angle. That means this thing is vertical. If it's a vertical line, it's going to look like x equals something. The x-coordinate is negative 4, so it's going to look like x equals negative 4. So again, horizontal lines, vertical lines, it's easy to find equations for them. You just need to know the x and y coordinates. Any questions about example 3? Okay. So, 2.3.2 deals with equations of lines. And how do you find equations of lines? One of the key things we're going to be using is this thing that's called the point-slope form, which allows us to find an equation of a line if we know a point of the line and we know the slope of the line. So, sorry, how many people feel like they know how to do that? Find an equation of a line through a point with a given slope. How many people don't feel like they know how to do that? Okay, I see no one who says they don't know, which hopefully means that you all sort of remember this from high school. So the key thing, the easiest way to do that, to find the equation of a line with a given slope, is this thing that's called the point-slope equation. Point-slope equation looks like this. Y minus y1 equals m times x minus x1. If you know a point on the line, you know the slope of the line, you can basically just fill those into this equation. It's the y coordinate of the point, x coordinate of the point, that's where the slope goes. So example 4, I'm going to show you the graph of a line. We're going to talk about how to find the equation of it. So, oh, sorry, which is number 46, D. So that guy there. No, it doesn't work like that. I was hoping I could select it and then just zoom onto it. Oh, it's 45D. Sorry. There we go. So here's a line. This guy here. The point on the line is -2, -5. And the slope of this line, well here, if I go over 1, I go up 1, 2, 3. Again, if you have your textbook open, you can probably get a better version of this than the scanned version. It's not very good quality. But yeah, if you go over 1, you go up 3, which means the rise is 3, the run is 1, so the slope equals 3. Which means I can come up with an equation for the line. Y minus -5 equals 3 times x minus -2. That's what the equation for the line is going to look like. Okay. Sorry, any questions about this guy? Example 4 here. Before, again, you can find a point on the line, you find the slope of the line, and with that you come up with the equation. Okay.
Solve for that though?
If I just say find an equation, no, you don't. Yeah. You mean simplify it, I think.
Yeah.
So you mean when you say solve for it. Yeah. You don't have to simplify it, I just say find an equation. One thing I can ask for is find what's called a slope-intercept equation. A slope-intercept equation is a simplified equation for a line. So if you pick different points in the line, you'll get different answers for the point-slope equation. However, the slope-intercept equation is only one slope-intercept equation. So when we're simplifying equations for lines, you always want to simplify it into what's called slope-intercept form. Slope-intercept form looks like y equals mx plus b. Y is something times x plus something else. The number in front of x is always the same thing as a slope. The b is always where the y-intercept is going to be. It's going to be where it crosses the y-axis. So if we can find those two numbers, we can simplify the equation, gives you more information about it. So example 5, now here if I say find the slope-intercept equation, that means find the equation and simplify it. Find the equation, simplify it to slope-intercept form. So there's the 2 points, 5, 2, and negative 2, 6. If we want to find the slope, we do y2 minus y1, which is 6 minus 2, over x2 minus x1, which is negative 2 minus 5. 6 minus 2 is 4, negative 2 minus 5 is negative 7. So the slope here is 4 over negative 7. Let me continue over here. Then if we use the point-slope form, we'll get y minus 2. Again, I'm using the first point. If you use the second point, you would get the same answer in the end once you simplified it. It would look different in this step, but it would simplify the same thing. Here we're going to have negative 4 over 7. Again, 4 over negative 7, so we use negative 4 over 7 times x minus 2. So if we want to simplify it, the first thing we've got to do is get rid of those brackets. We have negative 4 over 7 times x, and then negative 4 over 7 times negative 2. That gives you positive 8 over 7. So now if we want to simplify that, I've got to move the negative 2 to the other side. We have negative 4 over 7x plus 8 over 7 plus 2. Now that 2 we can think about as 14 over 7. So when we add 14 over 7 to 8, yes?
Why do we put x minus 2 and x minus 5?
Oh, thank you. I am moving too fast again. Thank you so much. 20 over 7. And then we have 20 over 7 plus 2. 2 is 14 over 7. So the answer, final answer will be negative 4 over 7x plus 34 over 7. There we go. Yeah, x is 5, y is 2, so it should be x minus 5. And again, it's better to leave these numbers as fractions than to try to turn them into decimals, because the decimals don't stop. The decimals keep on going forever, so you'll have to round them off with your calculator, and that gives you what's called an approximate answer rather than an exact answer. Any questions about how I did this example? Okay. Example 6. If I give you a... So here's an equation of a line. 7x equals negative 4y minus 8. What I can do is if I simplify this equation to slope-intercept form, I can then find the slope and the y-intercept of the line from the simplified equation. So here we have 7x equals negative 4y minus 8. So I'm going to move the 7x to the other side and the negative 4y to the other side. So 4y is negative 7x minus 8. Then to solve for y, I'm going to divide both sides by 4. So I'm going to get y equals negative 7x divided by 4 gives you negative 7 over 4x. And negative 8 divided by 4 is negative 2. So the slope here is negative 7 over 4. And the y-intercept is the point 0, negative 2. Again, the number in front of x tells you the slope. The number after that tells you the y-intercept. So using those two pieces of information, I can graph the line. So 0 comma negative 2 is here. If the slope is negative 7 over 4, that means the rise is negative 7, the run is 4, which means I'm going to go 4 spaces to the right and 7 spaces down. Put another dot there, and then draw a line through those two guys. And again, ideally you use a straight edge to do that, either a ruler or the side of your calculator or whatever you've got. Don't carry around one big enough for me to use on the board, so. Okay. Any questions about example 6 here? Okay. So, last thing I'm going to have time to cover today. I'm not going to have time to do 2.3.3 today. I think I need to, next time I teach this course, rethink the number of examples I'm doing. I'm trying to do one of each type of problem, but they're definitely taking me more time than I have. So one disadvantage of the point-slope form is that we cannot use point-slope form to get equations of vertical lines. The reason for this is vertical lines do not have a slope. They have an undefined slope. So instead, we use this thing that's called general form a lot of the time. And general form means something times x plus something y times y equals c. So it means both the x and the y are on the same side. One advantage of general form is that if you have something in general form, you can always multiply both sides by a number to actually get rid of all the denominators. So general form, you can always get away without using fractions. Where sometimes things in like slope-intercept form have fractions in them, which are a little bit uglier. So, one thing we can do is sometimes you ask us to find general forms of equations rather than slope-intercept form, like this one. I'm going to leave that graph there and start example 7 in the middle of the board. So, the first thing we want to go through that point, we want to have an x-intercept of 5. So one point is going to be negative 1, 6. The other point is going to be 5, 0. And the reason for this is that the x-intercept of 5 means it goes through x-coordinate 5, y-coordinate 0. X-intercepts always have a y-coordinate of 0. So if we want to calculate the slope, we're going to do y2 minus y1 over x2 minus xy. 0 minus 6 over 5 minus negative 1, which is negative 6 over 6, which gives you a slope of negative 1. Now, if we want to come up with an equation for that, we can just use the point-slope form. We have a point, negative 1, 6, and we have a slope of negative 1. So we have y minus 6 equals negative 1 times x minus negative 1. So y minus 6 equals negative x, this is plus 1, negative x minus 1. Again, negative 1 is positive 1. Multiplied by negative 1, we get a minus 1 there. Add 6 to both sides, y equals negative x plus 5. Now we want to find this in general form, which means we want to get both the x and the y on the same side. So I'm going to move the x over here, and we get x plus y equals 5. That is an equation in general form. means both x and y are going to be on the same side of the equation. Any questions about this guy? Okay. So again, I'm going to stop here. I am not, there's going to be a group, I'm not going to do 2.3 by 3 today, but there is going to be a group problem. So let me go back to this January 23rd. So here's the group problems for today's class. Now don't worry about the second one. I have not covered the second one yet, so I'm going to recycle this as a group problem for tomorrow's class. But you should be able to do number 1. Now to do number 1, you may need your textbook on page 103. If you don't have your textbook, hopefully you can look off someone next to you. I do have that one scanned, and I can put it up on the slide, but I want to make sure that people are able to see this first. And I have muddiest point cards in case anyone has anything they want me to go over at the beginning of class next. So again, if you have something you want me to go over at the beginning of class next class, please write it on the muddiest point card, and I will go over that. And if you have an answer for number 1, I want to show it to me, let me know. Oh, you know what I'm going to do? I am going to pull up the graph of a circle and draw it on the board, because I am going to, in like 5 minutes, 3 minutes, show you the solution to number 1, what the equation is going to look like. And to start that, I'm going to graph it. I'll give you a hint. If you can't locate where the center of the circle is from the graph that is in the book, you might be able to do it better from the one I've drawn on the board. I'm not very good at my high school math teacher was able to draw these circles, and I was always really envious of him. Still haven't learned that skill. Circles are ugly. Yes. Yeah, perfect. Yeah, exactly. That's all.
That's the final route.
Okay. One more minute, and then I'm going to show folks the answer for this guy. Okay. So first question, what number should go here after the x minus 1? Exactly. The x coordinate of the center is 1. If you can't see that from the picture in the book, just look for the highest point of the circle and the lowest point of the circle. Those should always be directly above and below the center. What about this number here? -2. The y coordinate here is -2. Again, look to the left. The part that's farthest to the left, the part that's farthest to the right, those should be on opposite sides of the center. Now, what is the radius here? 6? That 6 is the diameter. It's 3 is the radius. So the distance from, and again, it's useful to look at the top point and the bottom point, or the left point and the right point. I didn't draw this very well. The left point is at -2, the right point is at 4, which means the distance between those two is 6, which means the radius is 3. So the equation we will get will be x minus 1 squared plus y plus 2 squared equals 9. And that's the answer for this guy. So again, this is a very typical type of question you might see on the quiz next Tuesday. So if you're still confused about that, hopefully this helps. Otherwise, I guess there's still 2 minutes left, but you can go if you want to and just hand in. If you have assignments to hand in, throw them in the pile. If you have minus point cards.
I know that executing learning one basically just helps common sense.
That's all the one right now with like the math center.
What did you?
Yeah, I just asked the guy if there would be one thing. And
Just
yeah, it's like,
But this is one thing.
Yeah.
zero divided by it's like a guy,
It's 2 divided by 0.
Yeah.
Alright, I'll be scanning that. Thank you.
If you have like done some work and try to do it, he'll explain it. It helped out.
Oh, yes. Thank you for asking. I am so sorry
No,
about.
that was okay.
I really thought I had posted it, and I
Is it just
forgot.
under the files on the UFE?
It should just. It is now. It is now, and there's a folder called assignments.
Okay,
I
yeah,
just
that's-
created that folder and I posted. Yeah, I know. I have been scatterbrained this week, and I'm not entirely sure exactly why, but yeah. You're welcome.